Where'd you find this?
This is the lesson video for section 2.1 part B, in which we introduce proofs. A proof is a logical argument in which each statement is supported by another statement that we know is true. Now this is where we start getting into what I was talking about in class about how we have to justify everything that we say with a logical reason. We're going to start with proving solutions of algebraic equations are accurate. And to do that, we will use these different properties. The reflexive property just means that everything is equal to itself. For example, 20 is equal to 20. The symmetric property of equality is what allows us to flip around an equal sign. So if you know two things are equal, they're equal regardless of how you write it. The transitive property allows us to say that if two different things are equal to the same thing, they must be equal to each other. If A equals B and C equals B, then they must both be equal to each other. The addition property of equality, that's what allows us to add the same thing to both sides and still have the equation be true. The subtraction property of equality allows us, just like the addition property, but to subtract the same thing from both sides of an equation and still have it be a true equation. The multiplication property of equality allows us to multiply both sides of an equation by the same thing and still have it be a true equation. So then finally, the division property of equality allows us to divide both sides of an equation by the same thing and still have it be true. These four properties are where the majority of your steps to solving equations come from. The substitution property of equality means that, or states that if A equals B, then A can be replaced by B in any equation. So that allows us to simplify each step. So like when we add the same thing to both sides, then we evaluate down. Anytime we simplify, we're substituting in the result for what we originally had written. Then the distributive property, if you multiply into parentheses, you have to multiply the number that was out front by both parts inside the parentheses. So that's another simplifying property that we'll use. So we will use this format to write our proofs this semester, a two-column proof. A two-column proof has a column of statements and a column of reasons or justifications. A statement is each step of the proof, so the different conjectures you make along the way. And the reasons, those are the things that allow us to justify each step. Properties, definitions, theorems, postulates. We'll get into those stuff a little bit later on. Keep in mind that your very first block, that's always going to be your given or your place that you're starting. And you never want to just end with prove or done or something like that. You always need a reason for every step that you take, everything that you say on the left side. So here's our first example. With algebraic proofs, all we're doing is starting with the initial equation, and that should always be the first block, and it's our given, so that's our reason, that's what we're starting with. Then as we go down, we're just going to solve this equation and use one of those properties that I listed previously. So our target is to end here, that x equals 4. So that's going to be down at the bottom. And when I go to solve this equation, my first step would be to subtract 5 from each side. So minus 5 minus 5. The property that allows us to do that is the subtraction property of equality, because we subtracted the same thing from both sides. This is the property that allows me to say that this is a valid step in solving that equation. The next step 5 minus 5 is 0, so I just have 3x on the left. 17 minus 5 is 12. Whenever you take something and simplify and rewrite as the end result, that is substitution. I'm substituting 0 in for 3x. I'm substituting 12 in for 17 minus 5. From here, the next thing I would want to do would be to divide both sides by 3 to get x by itself, and that's the division property of equality. Then instead of 3x divided by 3, I'm writing 1x. Instead of 12 divided by 3, I'm writing 4. So that's simplifying. So that is the substitution property again. One more example. We're starting with this given equation, 6x minus 3 equals 4x plus 1. Then we're trying to end up at x equals 2. So a good first step for this equation might be to add 3 to both sides to move all the numbers to the right. The addition property of equality allows me to add the same thing to both sides of an equation. Then if I'm actually doing that -3 plus 3 and that 1 plus 3, that's substitution property. I'm not writing 1 plus 3 anymore. I'm writing 4 instead. I'm substituting that in. Then from here, it makes sense to move the x's all to the left side. So I would subtract 4x from both sides. So that is subtracting the same thing from both sides. That's subtraction property. Next, 6x minus 4x is 2x. 4x minus 4x is 0. Just leaves 4 on the left. So again, I'm just simplifying. That's substitution property. And then finally, I would need to divide both sides by 2. That's the division property. And then when I get the result of that division, when I simplify that, that's substitution property.